Welcome back. Let's get started with our final session before a brief summary session that we have. We're going to talk about industrial applications and opportunities for hydrogen. We have three speakers who are steeped into this area. Perlman from the Center for Houston's Future, Jack Broodo from Dow, and Tristan Aspray from ExxonMobil. Jack, thank you so much for joining us. When you and I had a conversation about this roundtable about a month and a half ago, it led to some very good questions and how great the opportunities are, but then also how deep the challenges and the scale are. And the scale is something that you always remind me of. So I'm very excited to hear what you have to share with us. Over to you, Jack.
Sure. Yeah. So for Dow, I mean, when we talk about solving these problems, we have pretty large facilities, and switching them from methane based to carbon to hydrogen based is going to be challenging. We've done quite a bit of engineering work in Europe initially. I think the big challenge is, I mean, I was listening to the various talks today, and people toss around phrases like we can get hydrogen down, blue hydrogen down to $100 a megawatt. That's $10 a million BTU at a 10 heat rate. It's important that people understand that there's a competitiveness issue here, and that there's been huge investment in the United States in the last decade because of shale and low-cost natural gas. And if we do this right, we'll be able to maintain that competitiveness, and if we don't do it right, that'll be a challenge for a U.S. Investment going forward. It'll be a challenge for the whole shift to a hydrogen economy, because other economies will take away jobs and take away opportunity. So let's go to the next slide and look at sort of what we see happening. So, transitioning at scale, we have about 7 gigawatts globally of power and steam that we generate and utilize. Virtually all of that's generated using natural gas. And then we have various feedstocks that we run through our ethylene plants. We have about 50 gas and steam turbines globally, over 100 furnaces, and 30 major sites that are producing all these various products. So this just gives you an idea of the scale. We use about a million barrels a day of feedstock, and so that's kind of just give you a feel for the scale of what the challenge is going to be for us. Next slide. So we done quite a bit of engineering in Europe, and clearly blue hydrogen is the best alternative. We studied both pre-combustion and post-combustion. We've talked to Shell and the various people you've had on the call here about various ways of doing that. Obviously, you have to have some method of generating your hydrogen from methane initially. Green hydrogen is a longer putt, not the smallest problem of which is getting water clean enough to make green hydrogen. That requires very high purity water to make that effective, and water supply in parts of Europe is also an issue. So green hydrogen is farther out the horizon right now, as far as we can tell. We think blue hydrogen is possible today. Also, if you build a steam methane reformer on your site, if you're making ethylene or you're running a refinery, you can put your off gases into some of these facilities and also convert them to hydrogen. So it makes it a very, very clean operation. So we think that's Gen 1. In Europe, that's clearly going to happen for two reasons. People talked about the wherewithal in Canada and the wherewithal happening in Europe. This is happening because of two reasons. One, the governments have put regulations in place, but also they've come through with major subsidies. And as those subsidies come through, then it makes it viable for corporations to continue their competitive position, or close to their current competitive position with those subsidies. And that's going to be a challenge in the U.S. because the U.S. doesn't have a history of the subsidy scale that Europe does. And then we think the next stage will be retrofitting the power sources. Right now, most of the European subsidies are directed toward the chemical plants and refineries, and not really directed toward power generation facilities. But we're going to have uninterruptible power, and intermittent power like you get from most renewable sources is hugely challenging for the whole grid. but specifically for chemical plants that run 24 hours a day, it's just not acceptable. So we're going to have very reliable power. And batteries at scale are just so far out, we don't see it happening in the coming decade at scale that we need. So we'll retrofit our turbines for hydrogen fueling over time. And then, of course, if we do have point sources over time, we'll have to go after point sources. Then Gen 3, we would hope would be advanced technology that lowers the cost of green hydrogen so we can begin shifting from blue to green. But we think that's probably 20 to 30 years away. Next slide. So these are, where we see the various requirements. The first and foremost is, people talk about how important this is, and I don't disagree with that, but consumers are going to have to be willing to pay for these carbon solutions, and they're not going to be cheap. They're either going to come through in the form of the cost of goods, or it's going to come through in the form of higher taxes, but some combination thereof. But it will happen. And then on power and steam technology, we have carbon neutral technology today, and then we need, if we can build convert our gas-fired power plants to blue hydrogen, then maybe they can run 24 hours a day. The big challenge we have today with natural gas power, of course, is that there's been the subsidies on renewables have driven more and more of the continuous sources of power, dispatchable power, to where they don't need to run as many hours of the day. So the cost of power per hour is going up and continuing to rise. And then CO2 and hydrogen infrastructure, there's been a lot of talking about that. My good friend Gordon did a good job of summarizing what he's doing up in Canada. And, I think these solutions are viable going forward. I'm hopeful that somehow we can figure out hydrogen pyrolysis and not need to inject all this carbon in the ground with an uncertain future of what happens to it over many, many years. We don't really have the experience to know that as industry yet. And then on process technology, Dow, working with other companies, is working on various process technology that are more carbon efficient or closer to zero carbon using electricity or whatever. But those technologies are also, sometime out in the future. We think some in the coming decade, and then others in the following decade. So I think that's all the slides I had. Is there another slide? No, that's it. Yeah, so that was really all the comments I was going to make, and if you have questions, obviously, I'm happy to take them.
Great. Thank you so much, Jack. We will have some time for questions at the end, but let's see if, I think Brett has still not been able to join, but we are very close to fixing the technical aspect in getting him on. And while we do that, Tristan, if you are on, maybe we can go ahead and get your remarks on the discussion, and we can go from there if Brett is able to join after that. Tristan, are you on?
Varun, good afternoon. Can you hear me?
Totally.
Can you hear me?
Yes.
Great. Well, I'm not going to use slides in the interest of time, so I'll just make my remarks now. If you want me to continue now, Varun, right?
Yes, Tristan, please go ahead.
Okay, well, good afternoon, everybody. And thank you, first of all, to the Energy Institute and the Cockrell School for the invitation to share some thoughts on the applications and opportunities for hydrogen towards the end of what's been a very interesting day. I think I'm going to reinforce a lot of the comments that have come previously. Hydrogen, of course, is widely used today, a global market of around 100 million tons per year, a little under 15% of that here in the US. It's supplied today mostly from fossil sources, so natural gas, coal, and some crude oil. And it's used almost entirely today in manufacturing. So methanol manufacture, ammonia, and various hydroprocessing steps in refining. That's the state of play today. But of course, the theme of this event is really more around hydrogen's potential uses as an energy carrier. And multiple applications are being researched and trialed and evaluated, and we've heard a lot about those during the course of the day. We believe hydrogen can play a role.
Interrupt you for a second. Do you have your camera on, or would you be able to turn it on?
I do have a camera on. Are you not seeing a picture?
No, not at this point.
Oh, that's interesting. It's saying here, camera is on. I'm not sure whether I've got a glitch here in the software. Varun, just for the sake of time, I mean, Why don't I just keep talking? You'd only be looking at my face anyway, so you're really not missing much.
Sounds
if
good.
You, if you just keep it on the agenda slide or the panel content slide. Apologies for that glitch there, but again, I'm not using slides. You'd only be looking at me. As I was saying, we believe hydrogen can play a role in meeting the significant dual energy challenge ahead of us. That is to supply increasing demand for energy globally while reducing environmental impacts, including greenhouse gas emissions. Low carbon hydrogen can be made in a number of ways to do that, through steam methane reforming coupled with CCS, also low carbon electricity being used to electrolyze water, the two key forms people tend to talk about with respect to low carbon hydrogen. Both of those are going to need policy support to gain further traction. That can come in many flavors. Support for research and development. For example, the Department of Energy's H2 at Scale program, and it's great, Varun, to see the program up and running now at UT late last year. Regulatory and legal frameworks will have to be established, as will standards for all parts of the value chain. And as we and others have advocated widely, a durable incentive for decarbonization through technology neutral economy-wide carbon pricing. We see low carbon hydrogen playing a particular role in those hard to decarbonize sectors, and also where it can leverage its advantage of zero emissions at the point of use. So specifically industrial plants, processes, industrial heat, transportation, particularly at the heavy duty end, and heating in general. Not to say other applications aren't and won't develop as well, but those are the areas where we see a particular opportunity for hydrogen. Texas is a great place to study energy and the associated infrastructure and integration. That applies to hydrogen as well. As has been said a number of times today, Texas already has a significant hydrogen infrastructure, production in the area of around 2 million tons per year, and Texas hosts the majority of around about 1,000-mile network in the Gulf Coast region. The core piece of that being Air Products line that goes all the way to New Orleans and is now being extended down to Texas City for additional applications. We've also since 2012 had in the region a hydrogen manufacturing operation where blue hydrogen is made and the CO2 is taken and sequestered, in this particular case, down at Port Arthur, the hydrogen going to a refinery and the CO2 going to EOR applications. So there's a lot of infrastructure already in place here, coupled with a high concentration of end users and industry and companies that can work with academic institutions on this whole topic of today's conference. It's no surprise that part of the hydrogen UT program, as we heard earlier, is going to be looking at the greater Port of Houston area and assessing potential additional opportunities for hydrogen application there. Over in Europe, a similar cluster is starting to take shape. The CCS there is referred to as the Port of Rotterdam CO2 Transportation Hub and Offshore Storage Project, better known by the acronym Porthos. We're a participant in that project along with Shell, Air Liquide, Air Products, and the Port of Rotterdam Authority. December last year, FEED was entered into on that project, and it has the intent of putting in place infrastructure that would gather emissions from the industrial complex in the greater Port of Rotterdam area. We're also involved with many other companies in the associated or linked H-Vision study, which is looking at how to leverage that infrastructure and develop additional uses for hydrogen in the greater port area. There are other similar projects emerging around the world being announced and getting underway. I'll just mention one more in the interest of time, and that was Equinor's announced hydrogen to Humber Salt End project. They announced that last year over on the other side of the North Sea in the UK, a large blue hydrogen producing facility taking natural gas, converting it to hydrogen, sequestering the CO2, and feeding that hydrogen to a number of industrial applications in the Humber Estuary. In that particular case, the project's also envisaged, from what's been published so far, to blend some of that hydrogen into a natural gas stream to feed a natural gas-fired power project, which is already up and running on natural gas. Clusters like the ones we've talked about and others have talked about can serve not only to facilitate new sources of hydrogen supply and demand, but they can also act as infrastructure facilitators of new technology development. And I'll just close with one future example of that. We are working and have worked for several years with a company called Fuel Cell Energy to develop molten carbonate fuel cells. These take effluent from power plants, etc., and capture, concentrate the CO2 for sequestration, but also generate power and some hydrogen. And we're currently working towards proving that technology at scale through a demo unit at our Rotterdam refinery, again, leveraging that greater Port of Rotterdam area infrastructure. Varun, again, apologies that you couldn't see me, but that'll conclude my remarks for today.
Great. Thank you so much, Tristan. There are lots going on with what you all are doing, and that is going to have a huge impact on how things play out here in Texas. So we will come back, hopefully, with a few more minutes for a question, but we have been able to get Brett to join us. So let's pull up his slides. I see his slides are up. Brett, welcome. So glad you're able to join, and please, we're ready for your remarks.
Okay, so if you go to the next slide, I have 4 quick points that I can make. So we've been talking about different applications all afternoon, and I just wanted to put industrial applications in scale. I mean, today industrial applications are really the key market for hydrogen. And if you look at what the potential is, and we're just talking about potential, I haven't sized these markets in terms of what the actual market will be, but if you just look at the potential, industrial markets could be quite large. In fact, they could be 3 times the size of the current industrial market and may likely exceed the potential available market for energy storage, renewable natural gas, or transportation, and I'll show that in a second. So there is a huge opportunity, I think, in the industrial space. What that means specifically is that we're going to see hydrogen being used in different ways. It'll be used today. It's used primarily as a feedstock in oil refining and chemical manufacturing, but we're likely to see new applications as a zero or low carbon industrial fuel or as an input to an integrated new manufacturing process, such as in steel manufacturing or perhaps in cement. And many of these applications really are ones which are considered hard to abate. So in other words, there aren't a lot of other options for decarbonizing these sectors. So hydrogen will play an extremely important role, but this will probably take, as others have said, quite a long time because they will require a new redesign of the existing manufacturing process. And finally, I think the Gulf Coast will be well positioned to be this industrial hydrogen hub, as many have already pointed out. We have a lot of the manufacturing facilities and hydrogen production, and so perhaps there is even opportunities to attract new industries that we don't have today, such as the decarbonized steel industry. So if we think broadly about this, and if we think about what the possibilities are, really, I think in some ways the possibilities could be endless. So let me just kind of walk you through some of the details of each of those points on the next page. So this is a page that I took from the U.S. Hydrogen Economy Roadmap that the Fuel Cell and Hydrogen Energy Association did. And it just shows kind of the sources in current industrial applications for the 11 million metric tons of hydrogen today. And as you can see, the primary use of hydrogen today is in refining, primarily in desulfurization of petrochemicals. So as has been mentioned, and work that we've done at the center basically has shown that Houston is a huge center for for the production of hydrogen, primarily for these sorts of applications. You do have applications in ammonia, and then smaller applications in things like methanol and metal processing. And in a second, we'll talk about it. If you just watch those bars and how they might grow, you'll see kind of how the market might change over time. On the next slide, you'll start to see how the hydrogen might play a role in industrial decarbonization as a fuel, as an integrated feedstock, or as an integrated heat and feedstock source, and then as continuing as a feedstock. So hydrogen is really well suited as a replacement, particularly in industrial high temperature heat applications, for which electricity may not be a good substitute. And so while there are some additional decarbonization strategies in things like cement or aluminum or glass, hydrogen could be the best alternative in some of those opportunities. And similarly, in steel production, steel is as I mentioned, is a hard to abate sector. And so the current technology, which uses a blast furnace and an oxygen furnace, that is a very difficult process to decarbonize, and hydrogen probably wouldn't work. But as we start to think about moving towards newer technologies such as direct reduction in arc furnaces, there could be a role for hydrogen to reduce emissions from natural gas or coal. And then finally, in feedstocks, simply replacing gray hydrogen with either blue or green in oil refining and ammonia production, and then perhaps looking at new synthetic methane production, converting methanol to gasoline, as I think as one of the other speakers has mentioned. Those could be additional applications for feedstocks. So as you can see, hydrogen could be a kind of a Swiss Army knife in the industrial sector for thinking about decarbonization. And if you look at the next slide and start to think about how that might play out in terms of how this market might grow, you can see the growth of potential. And again, these are just not markets that we know will happen. This is sort of the available market size. So you can kind of see it growing from the 11 million metric tons to perhaps as high as 43 million metric tons at some point in the future. And these numbers were taken from the NREL study, the technical and economic feasibility study that NREL did, as well as some work that the Resources for the Future has done. So I've combined a couple of different data sources to come up with this estimate. And then on the next slide, if you compare that market, that 43 million metric tons, to other applications that NREL has looked at in their technical and economic potential H2 at scale study, you can get a sense of the size of the industrial market compared to some of the other markets that we've been talking about today. So while the industrial market is going to be a difficult market and will take some time, I think it could be a very important market. And on the next slide, I think that the Gulf Coast in particular, and we've seen this slide before, is very well positioned to be a leader in this. And I think this is one of the things that we get excited about the Center for Houston's Future, is thinking about decarbonization as an opportunity for the Gulf Coast region, that as we start to move into the energy transition, Houston and the Gulf Coast region, and really the whole entire state of Texas, is really well positioned, given the resources, given the skills, given the physical assets that we have to take advantage of the energy transition. And that's, I think, an important mindset that we need to start thinking about how we can really be a leader and take advantage of this, and not be a hindrance to moving forward on these decarbonization strategies. So Arun, that's basically the overview that I had for the industrial sector.
Great. Thank you so much, Brett. Let me pose a couple questions to all of you, but begin by asking a question to Jack. Tristan, now we can see your video. Thank you so much. Yes. Jack, a question for you. You showed the timeline and how you were thinking in terms of different phases, and also scoping in terms of thinking about your emissions. As you look down 2 or 3 decades, and as you think about your scope of activities in terms of trying to mitigate the emissions, broadening out to your users and intermediate users, what are the biggest uncertainties that you see there? What could really, what keeps you up at night, if I might pose it that way?
That's directed at me?
Yes.
No, nothing keeps me up at night. I think these things always get worked out. Like I said, I think the big challenge we have is that as a U.S. citizen, I'm concerned that this is done correctly, because if you look at the foreign and domestic and direct investment that's happened in the last decade, I don't have the exact figure on top of my head, 70 or 80% of it was because of low energy price. And that's thousands of high-paying jobs. And if we do this right, we'll be able to retain that advantage. But today, 60% of China's energy comes from coal. And they got this big gas line coming out of Russia. They're talking about converting to a low carbon economy. It's much more difficult for them. But if you look at what's happened this winter, for example, with China having the big cold spell they had, coal prices, gas prices ran out the roof. We hit record LNG prices. Coal prices ran up, propane prices ran up. U.S. Gulf Coast, our prices stayed relatively low. It's a huge competitive advantage we have today. And if I have a concern, it's that we do this in such a way. We need to get there and get there as efficiently as we can, but it's going to take the wherewithal of the American public standing behind it. And if they're not willing to do that, there's going to be a huge down spiral, because we'll get started and we won't be able to afford to continue. It's just that simple. Just to give you an idea of scale, I've never seen subsidies like we see in Europe. In Europe, they're talking, I think Tristan talked about Pathos and Athos and the various projects that are happening there. The Dutch government's talking about bringing billions of dollars per project. Total is, I think, $65 billion in the first wave. I mean, the U.S. has never, ever subsidized at that scale. Germany's also looking at the same kind of numbers. And so if we're going to stay competitive, we're going to have to, the U.S. government's going to have to get their mind around this is the kind of scale of subsidy that's going to have to happen here. And all these things that we're spoken about today are simply not affordable from a competitive point of view. And if it's not, then it'll be fits and starts. We'll get started down a road, and then we'll stop. And then we'll get started and we'll stop, and we'll lose jobs, and we'll become uncompetitive. And so it's something that keeps me up. It's that, how do we work together as industry and academia and government to come down a road that can be a continuous road where we can successfully get there? And that's always difficult with vagaries of politics.
Thank you so much, Jack. Those are very important things to keep in mind. And as we also progress the discussion, including how policy and regulation might play and will need to play in all of this. Tristan, a similar question to you. Just as with Jack's operations, your work also entails global operation. You just mentioned your involvement, Exxon's involvement in projects across the world. What do you think, when you look at Texas and when you look at things happening in the U.S., where do you think the big lens needs to be put in and the big push needs to be put in from a policy perspective to really get things moving in how Jack put, in a very committed, in a very coordinated and forceful way? We really want to get this right.
Yeah, thanks, Varun. I think, as I mentioned in my remarks, I mean, policy support, people talk about green and blue hydrogen, but let's just call it low carbon. Going to need policy support and sustained policy support, and that's why we talk about a carbon fee, a carbon price that's predictable, durable, and gives industry the confidence to bring those pricings into the economics of projects, which, as you know, in our industry and related industries, projects have decades life of duration. So it's that confidence in the durability of those regulatory incentives, the clarity around standards. If you look at one of the topics that was touched upon a couple of times today was the potential to use existing natural gas infrastructure to transport hydrogen by blending. But if you move around different countries, even different states, there are different percentage limits, sometimes because of different pipeline designs and capabilities and ages and technologies, but also because different regulatory environments tend to come up with different standards. So there's some harmonization that's needed there as well. But I do want to come back to a topic you and I have talked about a lot, which is the great advantages of Texas in studying energy and new ways and forms of integrating and using energy and new forms of energy, or increasing forms of new energy, which is the ability to integrate all this existing infrastructure. So I think, as I try to point out in my remarks there, these specific locations where you've already got some of the activation energy, if you like, behind you. You've already got infrastructure, you've got concentrations of users that are already producing and deploying hydrogen. I mean, 100 million tons a year, it's a big industry today. It's a big industry with a lot of infrastructure. And I think the half of the UT project, which is looking at the greater Port of Houston area, at applications starting with those areas where you've got perhaps lower barriers to entry and getting going, are the places to really get started to trial some of these new applications. Not the only place to start, but those are places where, as we're seeing in various parts of the world, new applications for hydrogen are being trialed and discussed and researched.
Great, thank you so much, Tristan. These are very, very important times, and what we are all able to do over the next several years will really chart an important course. As Jack said, if we are able to really do this at scale or not, but I think, you know, there are lots of great opportunities there. Brett, before we move on to my closing remarks, let me pose a question to you. You know, for some of you might know, and others may not, but, you know, Brett was instrumental in deregulation of the Texas electricity market, you know, roughly 20 years ago.
20 years ago, yeah, over 20 years ago.
And chairperson for the Texas PUC. And so, you know, fast forward 20 years, Brett, you know, many of the things that the commission did when you were there enabled this coming online of, you know, a lot of wind and solar now that is, you know, central to discussion on green hydrogen. And we just heard about, you know, there are elements of cost and technology, you know, that still needs to be worked out. And yet, you know, you see hydrogen right smack in the center potentially of trying, you know, potentially being able to bring in the aspects of natural gas, as aspects of renewable, but really, as Tristan said, being able to use the entire infrastructure skill base, if you will, around Texas. So, you know, what's your sense of, you know, how, you know, you and the center has done a lot of work on hydrogen and the human resource that's there in Houston. How do you think, you know, in addition to the infrastructure experience and so on, the ability and the people that we have, how does that, you know, help us really take this in a very serious way?
Well, I think, you know, what we were successful in doing 20 years ago is really building a broad consensus for change. And we did it at the state level, and I think that's what we need to do, you know, for decarbonization, and we're just not there yet. So, but there are, I think, you know, I think with this, if we take nothing away from today, is that this is really an opportunity for us, and we need to be thinking about that. And then we need to be thinking about what those, not only what those policies are at the federal level, but what can we do at the state level? Some of those things might be in the form of removing regulatory barriers, but they also might be in the form of incentives. You know, when we structured SB 7, which was the deregulation bill, there was sort of something in it for everybody. There was something in terms of energy efficiency. There was something for renewable energy. You know, I think we need kind of an SB 7 for thinking about decarbonization in Texas, where there are opportunities to start to build and experiment on each one of these. Because when we started restructuring, you know, we had no idea that the wind industry in Texas was going to be 23 gigawatts. In fact, we couldn't even get the American Wind Energy Association to spend any time in Texas because they were too busy in California. And so you think about where all the energy on hydrogen is going right now. It's going in California, but we know that Texas is going to be a bigger market for hydrogen at the end of the day, at least in terms of the production of it, and maybe in terms of the applications. And in fact, the presentation that Joe Powell gave, I think, sort of indicates that Shell believes that this could be that we could be a global leader in the development and export of hydrogen. So that's really what we need to do, is we need to bring everybody to the table and start to create that sort of framework that we had for electric restructuring. If we can do that, then I think we can do some interesting things in the state. And it doesn't have to be expensive, and it doesn't have to be large at first. But I think if we can create that, as others have said today, then we can create we can start to build a virtuous cycle, just like we did, for renewables. And that's really what we should be doing.
Great. Thank you so much, Brett. And thank you, Tristan. Thank you, Jack. Thank you, Brett. This was a great session. We raised some really big issues, and that will continue to inform the conversation as we move forward.